And here, looking at the exponential function, f of x equals a to the x, and we're going to use a as 2 here, we have graphed this function. Notice that this point, -1 and be 1 over 2. 1 over 2, 0, 1, and 1, 2, where 2 is my base. F of x equals a to the x, where a is greater than 1, is increasing and continuous in its entire domain. As we've already talked about this, the limit as x gets closer and closer to -8, or closer and closer to negative infinity, then 2 to the x gets closer and closer to 0. As x goes to positive infinity, then the y value gets closer and closer to 0. This limit going to 0 makes the x-axis a horizontal asymptote, a line that it does not cross. And notice the 3 points. The graph passes through the points -1, 1 over a, 0, 1, and 1a. It's important to remember those points. Now we're still doing f of x equals a to the x, but now we're going to use 1/2 as my base. And notice what happened with this graph. Now it's a decreasing graph. But notice it still goes to the point -1, 1 over a, 0, 1, and 1 over a. So this is 1/2, 1/2, and the reciprocal of 1/2, this would be 2. Now, so if a is between 0 and 1, it's decreasing and continuous the entire domain. Now, as x goes to negative infinity, it goes to infinity. Graph goes to infinity. As x goes to positive infinity, the graph goes to 0, and the x-axis is still of horizontal asymptote. And it still passes through the points -1, 1 over a, 0, 1, and 1 over a. This is the exponential function. And it is important with exponential functions to know you have these 3 points always on the graph. If we look at these two functions, starting with f of x equals 2 to the x and replacing the x with negative x, gives you f of negative x equals 2 to the negative x equals 2 to the negative 1 over x equals 1/2 to the x. And so the two graphs we looked at are reflections across the y-axis. So notice we just would flip this graph over, we would get this one. So f of x equals a to the x, and a is greater than 1. Your graph starts 0 and is continuous increasing. If a is between 0 and 1, then it's continuous and decreasing. So that graph of f of x equals 2 to the x is typical for f of x equals a to the x, where a is greater than 1. For larger values of a's, the graphs rise more steeply, but they still have that similar shape. If a is between 0 and 1, the graph decreases in the manner similar to this graph. Here we can take a look at the graphs of several different exponential functions. Here we have in blue the f of x equals 2x and 2 to the x, or 1/2 to the x. In red, we have f of x equals 3 to the x, or 1, or f of x, and f of x equals 1/3 to the x power. Notice those are steeper than the ones with 2 and 1/2. And then f of x equals 10 to the x, it's even steeper. But the domain is still from negative infinity to infinity. The range is still from 0 to infinity. When a is greater than 1, the function is increasing. When a is between 0 and 1, the function is decreasing. And the x-axis is always a horizontal asymptote for all of these basic functions. Now, we've already looked at this graph, but let's do it again ourselves. We want negative 1/3. So 1/2 to the negative 1/3, that flips it and makes it 2 to the 3rd, or 8. 1/2 to the negative 2, flips it, it makes it 2 squared, or 4. 1/2 to the negative 1 flips it and makes it 2 to the 1st, or 2. 1/2 to the 0 power is 1, since every number to the 0 power is 1. 1/2 raised to the 1st power is 1/2, and 1/2 squared, which would be 1/2 times 1/2, is 1/4. So negative 3, 8, negative 2, 4, negative 1, 2, 0, 1, 1, 1/2, 2, 1/4. So we end up with this decreasing function the domain is all real numbers, and the range is from 0 to infinity, and that 0 is with a parentheses because it never really touches the x-axis.